I'm here in Tolentino on the east coast of Italy, where Nuova Simonelli have very kindly brought me down to show me what's behind the Aurelia, the machine you're using today, and how they make coffee. This is the R&D department. In here, there's engineers, researchers and designers. That's where a lot of the ideas take shape. It's also where the Aurelia started. But a lot of the ideas came from before here. This is Camerino, one of the oldest universities in Europe, here since 1320 AD. And the engineers from Simonelli and the researchers here have been working together for the last couple of years in learning more about the brewing process. A lot of the features in the Aurelia machine, the machine being used today, are the direct result of the research being done here. So now we're going to head to the Faculty of Mathematics. So we're here with Professor Piergolini in the mathematics faculty. And what you can see in the different computers here are different simulations of the extraction happening. What's interesting is each one of these simulations took around 4 days from a whole bunch of different computers to calculate as a result of a lot of time of work, which have now gone through to the design of the Aurelia machine, which is pretty interesting. So in addition to working with the Faculty of Mathematics here, Simonelli is also working with the Faculty of Chemistry. So we'll go take a look at that now. So in this room, they are analysing the chemical makeup of an extraction. And the idea is to, in this case, look at the amount of organic compounds versus inorganic compounds. And the goal is to have some scientific parameters to back up the sensory experience. So we're at the Polytechnic University in La Marche, Ancona. So we're here at the Measurements Department, the Faculty of Engineering, to see the experimenters researching and checking different materials such as rubber, carbon and porcelain through non-invasive systems. And let's take a look. So as well as working with Aurelia for the last couple of years, the researchers here have been working with companies such as Bosch, Mercedes, Boeing and Augusta. And one of the main things they've been doing is working on how to get temperature stability for the espresso machine. So the thermal camcorder allows them to analyze and experiment with different types of piping. So how long the piping should be, how wide it should be, the dimensions within the pipe, as well as playing with different types of flow restrictors to control how fast the water moves around inside the system. And all this allows them to create that perfect balance that gives them that consistent temperature stability in the Aurelia. It's very fascinating to see here just how much work and planning went into these machines before they even got built. This thing is a climactic chamber. And what it does, it creates conditions to test materials. So you can have conditions like from minus 15 degrees Celsius to 100 degrees Celsius, or 0% humidity to 100% humidity. That's all tracked through a data logger with 40 different probes. And the idea is that over long periods of time you can find out just how your materials and your machines are going to perform and how reliable they are. So we're here at the place where Simonelli make the boilers for the machines. Now, it's made from 99.9% copper, which is kind of very pure. It's a better conductor, it's safer, and they roll them to around 1.5 millimeters thick. A lot of it's done by hand, but some parts are also mechanized. But we're going to have a walk around and see what's there. So one of the few things here that's not done by hand is the welding. And it's in order to get absolute accuracy each time and have a lifelong guarantee. The workmen here will watch over each weld as it happens to make sure it's done perfectly well. It is an Aurelia group head. It weighs around 4.7 kilos, and it's that material type and it's the weight and the mass of it that help achieve temperature stability. The brewing, yeah, they're pretty heavy and kind of cool as well. A lot of the parts are pre-assembled before they're put inside the machine. So this forms all the piping and the wastebasket for the 3-group Aurelia that you're working off in the competition today. So as you can see, this is where they build the machines. This is the final stage of the assembly line where they do all the testing. Each machine gets tested roughly 4 hours before it gets sent off for packaging down there and for delivery. One of the nice things I've learned about the company is that a lot of the things I've been learning about, especially on the engineering side, are being taught to people who own the machines around the world. Roughly 240 days of each year are devoted to helping people get the most out of their machines and fine-tune them to get the best tasting coffee. That was particularly enlightening for me, hopefully for you too. I never imagined there was that many people and ideas behind the machine. Thank you for your time.